All right, so let's look at some more periodic trends. We're going to choose which is the larger species. And you'll notice here we're comparing an atom versus its ion. So we need to think about effective nuclear charge and number of electrons versus number of protons here. So here we have lithium versus lithium plus 1. So lithium has 3 electrons. Lithium plus 1 has 3 protons but only 2 electrons. So those protons can hold those 2 electrons closer. So in a cation, its neutral atom is always larger because you have the same number of protons but fewer electrons in the ion, so it's going to be held tighter, and so you will notice a smaller atomic or ionic radius. Okay, so now this is a little bit tricky. Iodine minus 1 or cesium plus 1. So iodine minus 1 is going to have 54 protons. Cesium plus 1 is also going to have 54 electrons. I said protons, electrons. So they both have 54 electrons, but notice cesium has 2 more protons than iodine to handle those. So the more protons will hold those electrons closer. So the negative ones are going to be larger. Okay, here we have a metal versus, or a neutral atom versus its cation. Fewer electrons, same number of protons. Neutral one is larger. When we have anions, same number of protons in oxygen, there's 8 of them. Oxygen minus 2 has 2 more electrons. A lot harder to hold on to those, larger electron cloud. All right, so let's look at this next one. What is an isoelectronic series? An isoelectronic series means all of these have the same number of electrons. How many is that? Hopefully you'll notice all these have 10 electrons. Isoelectronic. They all have 10 electrons. So decreasing radius, so that means we want the largest to the smallest. So to make sure you read the question right, I have to break that down. Okay, so the largest is going to be the one that has fewer protons, more electrons. So of these, fluorine has 9 protons, oxygen has 8, magnesium has 12, sodium has 11. So all of these have 10 electrons. Which one is going to be able to hold those 10 electrons the least well, or the worst, not the closest? So the fewest number of protons, so that's going to be oxygen minus 2. So more protons is going to be smaller in this case. F minus 1, Na plus 1, Mg plus 2. Okay, now here we want to choose the element with the higher first ionization energy. So that means we are going to be pulling off an electron. Okay, now as we go across here, it gets harder to pull off an electron. So they really like these. So which one likes their electrons more? It's gonna be tough. Okay, so it's gonna be, takes more energy, so it's gonna be increasing as you go across the period. As you go down, there's more electrons, they're further away from the nucleus, so it's easier to pick them off as you go down. So as you go down a group, it's going to be decreasing. So which one is going to have a higher first ionization energy? Which one is going to be harder to pull off the electron? So here you would say, well, it should be harder going across, but easier going down. So technically by periodic trends alone, you really can't tell. Now, if you want to make the argument and say, but phosphorus has a half full shell, I can agree with that. So based on periodic trends alone, you can't tell. It's probably this one, but we're not going to circle that very dark. All right, silicon or chlorine. So which one does not want the electron to be pulled off? Chlorine. Chlorine is harder to pull off the electron. It takes more energy. Phosphorus or antimony, which one does not want it gone? Phosphorus. Gallium or germanium? Germanium. Increases as you go across.